So good morning once again, colleagues. So today we are looking at a new episode of Surds. And Surds are not new. You have learned them at all level from Senior 2, Senior 3, Senior 4. So the same content is going to be developed in A level. We are just adding on in advanced level. And these Surds are very important. They are useful. Especially engineers use them when they are constructing the bridges. They normally use the idea of Surds. So it's not a matter of saying that Surds are going to help me where. So those Surds are used in the bridges by these engineers. They apply the methods of Surds. So feel free and be comfortable when we are following them. So when we cannot simplify a number to its simplest form, or we cannot remove a square root or a cube root, that number is termed as what we call a surd. Or others, you normally use the word irrational numbers, numbers which have no exact square root. So when we cannot simplify the number or remove the square root, or removing cube root, or remove the cube root, that number is called surd, or an irrational number, And when we talk about an irrational number, we are meaning numbers which have no exact square root. For example, the square root of a, square root of ab, square root of 2, square root of 3, root 5, root 7. Those ones, they have no a perfect square. We call them irrational numbers, or in a simple term which we call surds. So we are going to look at how to simplify these surds, the simplest form of surds. The simplest form of surds. So we're going to look at numbers when they are in a bigger, complex way. How can we reduce them to the simplest form such that everybody can easily read and interpret it very well? So here we normally say that if a number under the root sign has a perfect square, then that one, it can be reduced to its simplest form of that. So we are going to be taking examples on them. Example 1. Simplify the following. Simplify the following. Part A, root 8. You can see root 8 can be broken into other numbers. And when you are breaking, think of two numbers. One number must have an exact square root, and one number must not have a root. When you multiply them, you come out with 8. For example, like this one is, we have got which number? Think of two numbers. When you multiply, one has got exact square root and a perfect square. Like 4 times 2. Each number now say has the square root. This becomes root of 4 times root of 2. Do we know the square root of 4? Yes, this one is a perfect square, which becomes 2 times root 2, which becomes 2 root 2. You can see that we have tried to simplify that number from root 8 up to root 2. As we are adding on more examples of that, such that we can easily understand how can we reduce these huge numbers to the simplest form. Part B, root 12. Still you can see it is a bigger number, but you can also reduce it. Think of two numbers. When you multiply those two numbers, you get 12, out of which one must have a perfect square or exact square root, the number which you know. Like here, if I say 6 times 2, 6 has no perfect square, is not a perfect square, even 2 is not, that one does not work here. Another one is 4 times 3. 4 is a perfect square because the square root of 4 is what? Is 2. But 3 has no exact square, that one can work. So this is the same as root of 4 times 3. Then every number say as 4 times root 3. Do we know the square root of 4? Yes, it is 2. The square root of 3 we don't know, it is irrational. Remains 2 root 3. Part C, root 18. Root 18. Think of two numbers. When you multiply them, you come out with 18, out of which one must have a perfect square. So these ones you can say 9 times 2. Do we know the square root of 9? Yes, that is root 9 times root 2. Square root of 9 is 3 root 2. Another one is root 27. Think of two numbers. When you multiply, you come out with 27, out of which one must have exact square root. What are those numbers? 9 and 3. Root 9 times 3. 9 times 3 you come out with 27. So out of that you get root 9 times root 3. The square root of 9 is 3 root 3. Then another part is root 72. How can we deal with root 72? So this is the same as root of 9 times 8. But that one will not work for you. Why? 8 is also bigger like in the first one. So what you do, don't use that one. You need to use the one which is simple. For this one will not work because it will push you to another level. So we are going to say root 72 is the same as root of 36 times 2. You can see now that one is bringing one which is awesome, but this one could not bring what I want you to come out with. So this one becomes root 36 times root 2. What is the square root of 36? Is already 6 root 2. You have already tried to simplify that one up to its simplest form. So now we are now moving on to addition and subtraction of surds. With surds, they can be added or subtracted so long as the root in question is the same. They can be added or subtracted. But if the roots are not the same, automatically they cannot be added together. So we are going to look at addition and subtraction of surds. Addition and subtraction of surds. Surds can be added or subtracted if they have the same irrational number. I.e., if I have a root x plus or minus b root x, this is the same as, you can see that our irrational number is x. You can see this one is bearing root x and this one is also bearing root 2x. But we are having the first one is a plus, or if you are not talking about plus, you can even do the subtraction. What we do here, add these ones together and the roots remains together. So what we're going to have here, we're going to have a plus or minus b, then root x. That's what we do with addition and subtraction of surds. You can take examples. Add the following. Roman 1, 3 root 2 plus 4 root 2 plus 6 root 2. So you can see that our rational number is 2. A number which has no exact square root is called irrational number. That means we have root 2. Now you can see that the question, the root 2 is common everywhere. What are you supposed to do with this? You are supposed to add the numbers outside alone. So you're going to say 3 plus 4 plus 6, then root 2. Can we add 3 plus 4? That is 7 plus 6, you get 13 root 2. That's how we add them. Can we go to Roman 2? I say root 8 plus 2 root 2 plus 3 root 3 plus root 27. What we're going to do is this. When you find a number is bigger, first simplify it like what we have tried to look at in the previous examples before you try to add. For instance, root 8 is the same as root 4 times root 2 plus 2 root 2. This one is in simplest form, plus 3 root 3 plus root 27 is the same as root 9 times root 3. We go on and we try to break. Square root of 4 is 2, then root 2, plus again 2 root 2, plus 3 root 3, plus square root of 9 is already 3 root 3. What is happening now? We correct like terms. Those ones with root 2 add their corresponding numbers. So you can see here 2 plus 2 outside root 2. This becomes 2 plus 2 root 2, then plus. Still here with root 3 we add those numbers. We say 3 plus 3 root 3. Very good. 2 plus 2, you come out with a 4 root 2 plus this is 6 root 3. You have finished adding them. Then you cannot proceed by adding. Why are we not adding these ones? Because they have different irrational numbers. So you can stop from there. Don't guide and say 4 plus 6. Then you say 10 root what? Because the roots are what? Are different on that. Then Roman 3, you can say root 3 plus 4 root 2 plus 5 root 3 plus root 12. So what we're going to do is this. Still, when you find a bigger number, first simplify it to its simplest form. Reduce it to its simplest form. Then at the end, you add the corresponding irrational numbers. So this one is the same as root 3 plus 5 root 3 plus, I can break that, root 12 is the same as root 4 times root 3 plus 4 root 2. Go ahead. This is root 3 plus 5 root 3 plus, the square root of 4 is already 2 root 3 plus 4 root 2. Then can we add the corresponding, which number is here is 1. We say 1 plus 5 plus 2 root 3, then plus 4 root 2. We got 1 plus 5, we're getting 6 plus that, we are getting 8 root 3 plus 4 root 2. That's how we add those static numbers. So if we try to look at the subtraction side, we can also go ahead and we do some examples related to that. So equally as the way I have done, even if it is about to subtraction, you do the same. You subtract the corresponding irrational numbers. Those ones with edifying, you leave them, you categorize them according to their groups. So we are moving to another example, that is example 2, which is consisting of subtraction. The first one was containing addition. So example next, example 2. Subtract the following. Subtract the following. Subtract the following. Part A. 3 root 5 minus 2 root 5. So what I'm going to do with this, the same story how you did them at O level. That's why we are first developing this content before we move on into the details, so that things can be paramount on your side. So the same story here. You can see the rational numbers are the same. What we do, we only subtract the corresponding. This is the same as 3 minus 2 root 5. 3 minus 2 we get 1. It is 1 root 5. But in mathematics, even if you don't include for us 1, we shall know that behind it is 1, just write it as the root 5. So we are done with that addition and subtraction of what? Of surds. I was just giving you a highlight on that. So we can now move to the multiplication of surds. Then our most emphasis will be on the division side, where we shall deal with rationalization. But you can't go to rationalize when you don't know how to deal with either addition or subtraction or multiplication. So we are moving to multiplication of surds. Surds can also be multiplied, and when we are multiplying here, a number and a root is multiplied by the number with its root. But the number outside the root is also multiplied with the number outside its root. Surds can be multiplied. Surds can be multiplied together. And in this case, and